We need clean, constant energy. Terrestrial renewables like sun and wind don't work all the time, but power from space promises to be limitless, uninterrupted, and pollution-free. A solar panel in space is 10 to 24 times more productive than the same panel on the ground. A panel in geostationary orbit receives full, uninterrupted sunlight 24/7, unlike on Earth where sunlight is filtered and disappears at night. The 1970s Vision was a power station the size of a city. This 50,000-ton satellite was projected to generate 8.5 gigawatts of power, enough to power 5 cities the size of Boston. 3 numbers kept the dream in science fiction. The prohibitive launch cost was over $54,500 per kilogram. The construction was impossible, requiring an, quote, army of astronauts. Lost motivation followed the 1980s oil glut, with prices falling dramatically. Today, the same crises have returned, driven by geopolitical instability and the need for energy independence. The key difference is what's possible today, as the tools have fundamentally changed. 3 revolutions enable a renaissance in space power. We now have radically cheaper launch costs, advanced, lightweight solar arrays, and autonomous robotics for assembly in space. New tools inspire new plans. Today's engineers are pursuing 3 distinct and competing visions: the evolution, the swarm, and the reflector, moving beyond the original 1970s blueprint. Vision 1, the evolution, is a modern, streamlined behemoth. Key innovations include modular design, highly efficient electric propulsion, and high-performance solar panels. The hurdle is an estimated $20 billion cost and a decade-long construction timeline. Vision 2, the swarm, is a radically different approach. Instead of a single entity, it uses a swarm of individual satellites. The key shift is from an all-or-nothing megaproject to an incremental, scalable system. A swarm changes the entire business case. Transmission shifts from microwaves to lasers. Scalability allows for pay-as-you-go power. This approach targets niche markets first, such as space-to-space power or remote military bases. Vision 3, the reflector, is a completely different approach. The core concept skips converting photons to electrons, instead using flat mirrors to reflect sunlight directly onto existing ground solar panels. The goal is to extend operating hours, particularly during peak demand at dawn and dusk. This model features a Terminator-chasing orbit, targeting peak electricity demand. The central hurdle is light pollution, as each satellite can be, quote, a couple times the brightness of a full moon. Mitigation focuses on precise targeting to avoid unwanted light. A snapshot of future power contenders shows the challenges. Cassiopeia faces a massive upfront cost. Laser Swarm must overcome weather issues and public perception. Reflect Orbital needs to manage light pollution and public acceptance. Space-based solar power is becoming an economic eventuality. Launch costs have plummeted, as shown by the drop from the Space Shuttle era to the projected cost for Starship. The primary barrier is no longer the cost of getting to space, but the price of electricity on the ground. The question is no longer if we will build power stations in the sky, but what form they will take, and what trade-offs we accept. We must ensure we don't solve one crisis only to create another, leaving behind a sky that no longer inspires the next generation.